My father did some famous work on network flow algorithms. He's done a lot of papers on network flow algorithms. I took a course from him. All right. Yeah.
What is the importance of this one? Because in 2011, I couldn't understand what does it do.
All right. All right. So, suppose you're a trucking company, and what do you have? You may have many sources. So there are all these factories that are producing things, and you have many sinks, which are stores that are selling things, and you have many commodities, right? You have widgets and Twinkies, and right, and then each highway you have constraints of how many Twinkies can go along your highway per minute, and you want to think, how do I get as much stuff from the factories to the stores as I can, right? So that's our problem. And it comes up lots in, they call it OR, Operations Research. I don't know, it's a big topic and also you can do reductions, right? So if I have an algorithm for this problem, we're going to show you how you can get an algorithm to decide who you want to marry, all right? Solving the marriage problem. It comes up a lot, all right? So also, it's an algorithm that's covered in every computer science department in third year in the world, as far as I know. It's just the classic problem that gets covered. And so we should cover it. Also, it has a real nice feel to it in that it's an optimization problem. What is an optimization problem? As I think we're about to say, an optimization problem is when you have an input, and for every input, there's an exponential large possible set of solutions, right? And each solution it's easy, given a solution, to calculate what's the cost of that solution, and is it a valid solution, right? And so what is our goal? Our goal is, given an input, find a valid solution with optimal cost, right? So that could be min cost or max cost, depending on which game we're playing, right? So the rest, in fact, this slide is talking about the rest of the course, all right? So what we were doing in the past, how is that different than the past, is we have an input that has some specific output, right? And here, well, there could be many solutions that meet this condition. There could be many solutions with the same cost, right? And this is sort of a search problem. And one nice thing about this problem is it has a nice clean solution, polytime solution, because most of these problems are NP-complete, meaning that we don't know a polytime algorithm for them, right? So that's another reason we cover this topic. In fact, another reason we cover this topic is a huge problem in industry is linear programming, and we're going to cover that too, and we're going to see that this is an easy example of linear programming. All right, so there's a bunch of reasons we cover this problem.